This talk can go either really, really well or very, very badly. And it can go badly because it's a lot of slides. It's a long journey from the way people write JavaScript all the way to reactive. I have 87 slides. I'm not scared because for two reasons. Every slide kind of builds on the previous, so it's very incremental. So there is not a lot of information. It's not like a huge slide content. And second, you guys look like a very smart group, so you can keep up, right? First of all, why am I risking my physical safety talking about JavaScript? As you know from Keynote, people slap you if you describe JavaScript as a language. Certainly, it looks crazy, right? Like the guy who, it's a joke, but the guy who invented JavaScript doesn't understand equality. He doesn't even understand less than operator. It's completely crazy. And yet, it matters, right? So JavaScript matters a lot. It used to be, kind of limited to callbacks and sending emails and, blinking tags and stuff like that. But now it's everywhere. I can program using the same tools, everything from my server to my website, to my mobile, to my embedded device, everything. So JavaScript is everywhere. No, that's not where I want to go. If we go to Stack Overflow and you look at number of open positions for JavaScript, it's almost 1,000, right? Who wants to venture guess what functional language is right next to it? Scala, Java. Okay. Right? Yes. This is very unfair. But if you look at number of open positions, this is not even true representation, because a bunch of positions, for example, for a camel come from only like 2 companies, right? If you look by number of unique companies by language, it's even worse. You know, Thomas, right? Anyway, so now you are all angry mob, right? But if we actually, discuss things that were most popular, we would discuss this dress and its color. Look it up. It's ridiculous. What's that? Who thinks this is white dress? Raise your hand. Who thinks it's a black dress? Exactly. No, I'm not going to get sucked into this. But what's important from language popularity is that if we take all the functional people who in the world and we improve them by a factor of 2, right? We improve everything you guys do tremendously. We're still going to make a lot less impact than improving JavaScript developers by 10%. This is a huge area, and if we kind of can do incremental steps, we can have a huge impact on software quality. I'm a software quality fanatic because I'm tired of crappy software. It used to be that you had to install the crappy software. Now you can't even go to a website and use it because it's crappy. Try loading any restaurant on your iPad. You can't use it. Like, what? So I work at Kensho. Kensho is a startup. We're in Boston and New York now. We provide financial analytics software. Basically, we can answer in a couple seconds a question that is on everybody's mind. How does like a cold event, like cold temperature, affect the price of bananas? Right? You're all wondering, should I buy banana stocks when it gets colder? People sit at home. They get hungry. Should I buy stock? We can answer that. So we have a huge Angular application. It used to be Backbone. We have rewritten it in Angular. There's a lot of Python server-side code. The application, because we're a startup, we're still trying to find the features that are going to sell, is very modular. We constantly, based on the feedback, rewrite, add new features, and it has to work. That's our, front face. The customer pays to access our website and use this app. We cannot fail. Wait a minute. That's a whale. What's that part of my presentation? So anyway, so we have this app, right? We're trying to sell it. We're trying to add features. We're trying to make sure it works. And the code keeps growing and growing, right? Like every software. We were lucky. We're a startup. We start from trash. We don't have legacy code. We don't have huge, Java. I used to work at Mathbox, so I know about legacy code. So what we want our JavaScript code to be is as easy to understand as English, or even simpler. So my native language is Russian. Russian is a very ambiguous language. English is much simpler, but we want our code to be even simpler. I don't know why it goes backwards. Crappy software. I always want my software and code produce expected result. Nope. Like that was unexpected. I want it to be simple to test. We want our code to work. That means we want to test it. It has to be simple. And finally, we don't want to write the code over and over, right? We want to write one widget and assemble it a larger application. We want to write simple processing pipeline, reuse it over and over again. So I don't have to sell you on this. We want to use functional programming in JavaScript to implement reactive programming patterns, right? This is kind of our solution to the code complexity. You guys program, functionally because you think that this is a good solution. But what happens? Oh, what happened lately is that you can buy a book. It's called Functional JavaScript. You can listen to videos. Netflix is a huge company that pushes a lot of reactive UI, paradigms using JavaScript. So you can watch a bunch of videos. They kind of do the same what we wanted to do. And it has two major parts. Functional programming in JavaScript, small pure functions. I know pure is impossible, but they're kind of clean. Yes? I know. I hope you would not notice that. PayPal is the second largest company. PayPal is here. The guy moved from what's in charge of UI at PayPal right now, came from Netflix, so he brought the same kind of approach. I apologize for Netflix. Maybe one day. Who knows? Okay. So we have two parts, right? We kind of have asynchronous. I'll talk about asynchronous performance. Why? And then the reactive UI, right? Like the previous presentation was actually pretty good, right? It's all a sequence of events. So I'll show how we implement, we have the whole callback how we think about everything as a sequence of, let me just go to computer because this is, okay, everything is a sequence of events. Browser side, server side, doesn't matter. And we process all the streams using a very standard, very small set of operations. And then you tell this to your developers, and they are like, what are you talking about, right? And the problem is we have smart people working for us. But most of people come from languages that are not functionally oriented, if they come at all, right? I came from C++ side. I'm a computer graphics and computer vision person. When I actually looked at JavaScript development, I hated it. Like, I hated it so much because it was painful, right? Other people come from Python or maybe Java, or maybe even a UI designer who kind of started in CSS and styles and then kind of, oh, I have to implement jQuery, callback or something, right? So you cannot assume that they come from a Camel, a Haskell, a Scala world, right? You have to take people, the ones you get, who are smart, but they're not used to program the web the way you want them to program. Another important thing is if you look at the bottom row, your developers are usually, especially at startup, doing everything. So some people spend majority of time on the front end. Some people only occasionally touch your front end. So you want your code to be simple enough so that the person who only spends 10% of the time working on front end can come in, fix a bug or implement a new feature and not break anything else and leave. It's not a problem, or it's not a question of hiring junior developers versus senior. JavaScript is huge. You add browser APIs and styles and DOM and frameworks. Everyone is probably more proficient in one area, even if they're junior or senior. Some people just do jQuery and styles. I never touch jQuery, so I'm somewhere here, right? I only touch JavaScript code. So we want to take every developer, no matter what the skill level, right? And kind of move it and train them and get to where we want them to be, right? So out of all talks at this excellent conference, this is the only useful one. Because I'll show you how to take anyone and get them to program in functional style and reactive pattern. Everyone else just preached to the choir, right? Everyone said, oh, use Scala, or use a Camel, or Elm, or ClojureScript, or Clojure, right? I'm going to show you how to take a step and bring everyone to functional style, no matter what the language is. I use JavaScript. Of course, I cannot jump all the way. No? OK. I have to take a bunch of baby steps. I think the internet here is bad, that's why. So, bunch of steps, we'll go through all of them. It's a lot of steps, right? So, we usually get people who write, it's not imperative, it's procedural code, right? Like plain, variables, leaking, global stuff. And then, at most people in JavaScript use object-oriented features, but we want to actually go all the way to get to reactive part. You don't have to learn everything. I personally think that if you want a shortcut, you can just look at the orange stuff. But of course, it doesn't matter. If I don't show you code examples or do live coding, if you code a tree in a forest and don't share with GitHub, has it really happened? So we're going to look at a small problem. We're going to take an array of numbers. We're going to multiply those numbers by a constant, and we're going to print it. We're going to look at this problem over and over again, and every time we're going to use more powerful feature. But the code should look simple and be functionally oriented. So we start with a very simple solution, right? Why there is no syntax highlighting? It's on my, anyway. So this is what you get when you hire a JavaScript developer, right? It works. I hate for loops. I come from C and C++, and for loops always cause problems, right? Like, always. It was ridiculous. And also, inside the for loop, we're doing multiplication and then printing, so we're mixing concerns. So the first thing we want to do is to tell the developer to separate the concerns, right? Separate multiplication from printing from for loop. Already better code. This is easy, right? You can give this advice during code reviews. But I think the overall principle that I always ask from myself and from my team is, can you make the code as boring as possible? And I'm not saying like Java boring, right? Like they're both like, oh my God, I have to look for like 10,000 lines of code to find multiplication and print. I want a code that doesn't surprise you, right? So the for loops will always surprise you, right? But anyway, it will drive you crazy. Using this, that means using like object-oriented context and assuming that this is what you think this is, will surprise you. Using anything not inside the function will surprise you. So what's the most boring solution to this problem, right? Pure functions. So multiplication. I consider print, pretty pure myself. Output depends on the input, some blah, 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 no surprises. You cannot prove that the function is pure. It's equivalent to a halting problem. But what you can do is prove or test if it's pure against a set of unit tests. So if you write unit tests, I have a tool that takes all your functions and mangles them up and moves them out of a context and recreates them and then runs the unit test, and if everything still works, then your functions behave pure. Just like boring parents raise boring kids, boring pure functions make boring pure children. So if I have multiplication and I can do partial application from left to right using built-in JavaScript bind operator. So this is language feature. I'm not using anything yet, right? I'm just using plain JavaScript. I can provide one argument A or both arguments. I can create a print method. Very boring code, right? No surprises because my original functions are boring. I know you're bored already, but let's move on to something more interesting. So Lisp is a great language, maybe, but it operates on the concept of a list or array. So JavaScript in current version has an array. An array has a bunch of prototype methods you can run, like map or filter or for each, and reduce. And reduce is the best one because you can implement everything else in terms of just reduce. So you can use it on any array. So instead of your for loop, you can implement numbers for each and then run your pure functions. So you eliminated for loop. At our company, our static analysis actually bans using for loops. You have to use for each, or you have to provide an exception, like specifically. So we completely eliminated for loops. We kind of mixed concerns, right? We kind of create process number functions just because we wanted to first multiply, but we can actually pipeline, and we can say number map little function and then for each print. So we can express the desire or express our pipeline semantically using built-in methods. So already the code is boring, no surprises, produces expected result, and is simpler to understand because it kind of mimics the English language. And then, most of our code just manipulates lists of data, right? We get something from a server, we want to show it in a table, we want to compute min and max, we want to compute maybe standard deviation, we want to show it as a graph or anything. We manipulate a bunch of data. And so what we noticed is, or was, if we use built-in methods like map, filter for each, sometimes it's not enough, right? The list of built-in methods is pretty short. But people recreated them using third-party libraries. So usually if I have to use reduce, I can find a library that has reduce and it has a bunch of other methods. So people think of JavaScript as widgets and crappy stuff. If you look at NPM registry, which is the largest public repository, I think it just surpassed Ruby, the top 2 out of the top 3 most dependent packages are these utility belts of little functions, like map for each and a bunch of others. Called Lodash and underscore, which are both. Lodash is just a fork of underscore, but now it surpassed it. So you can think of this as a good thing. People use functional stuff in JavaScript and they see the need. Or you can think of this as a bad thing because the language doesn't come with built-in functions, so everyone has to use them. But the most important thing is that people use them. So I'm ready to be slapped. Anyway, so I'll use Lodash. Instead of built-in bind, we can use partial. We can pipeline our numbers and run map, and for each we can print, does the same thing. We can combine things differently. In all cases, we followed the built-in order of arguments. That means I put my array first, or I run my map on an array. But then people came along and they said, well, it doesn't really make sense because if I run let's say I want to multiply everything by a constant, I usually know the constant first. I don't have the data yet, but I know the constant. So if we have a built-in way to partially apply from the left, I usually know the first arguments. I don't know the array first yet. So there's a new library called Lambda that just took everyone by storm, because these are smart guys. What they did, they enabled currying by default. That means you can just partially apply until you get all the arguments filled in. And you always put the data last. So what we think is a prerequisite for a functional language, right? are already there. Just use this library, create a pipeline of your transformations, you get back a function, and then you just run it on your data. And you profit. And you profit because this is very testable. If my code is very, very testable, it works. I can feel good about modifying it. I can sell it to clients and not constantly debug problems. And I can sell new features. So profit. We'll get to that. Yes. Don't run ahead. Reactive was the very last thing. Another cool thing is that these abstractions, these libraries, they don't care if it's an object or a list, right? They can usually iterate over everything. So you get more power. So just to compare, when I worked in C++ or Java or C#, I used to write a lot of these things like, I need a piece of business logic, so I would write number multiplier class, and it would have a method add, and I could add numbers, one by one or all of them, and then I could maybe multiply and then print. So I would write a lot of custom logic, making very smart objects or classes, and passing very simple data. Like in this case, the data is only numbers, right? 3, 1, 7, and 2. But now I write use very dumb objects, right? Just a list. But I build a very smart pipeline. I pass pieces of logic. And there is a very good quote from the guy responsible for Algol. And he says, it's better to have 100 functions operate on one data structure, think list, rather than have 10 operations operate on 10 different objects. So if you think of your data as a sequence or a list, and you have a bunch of standard operations, it's a lot more powerful. No? Oh, by the way, look it up. There's a huge article of his sayings like that. It's hilarious. You should definitely find it out. I'm going to skip transducers because we don't have time. Unfortunately, at this point, we have to say goodbye. Not to me. No, you're not that lucky. First goodbye we have to say is to return values, and which is very weird coming from imperative style like C, Java, where you run a function, you get a result. You map something, you get a result. Notice when we start doing pipelines, we don't get intermediate values and we don't get a result back. We fire off these numbers somewhere in a nebulous pipeline, and we never actually get anything back. Right? There are no return values. So bye-bye return values. I used to create a bunch of intermediate functions that used to pass stuff around. I don't need it. Point free is not pointless, right? If all you do is pass one variable, from a callback to another function, you can adapt your callbacks. This is actually much easier to read, and that means fewer surprises, testable, easy to understand, not break profit. Side effects. So immutable data structures are not part of JavaScript, but a whole bunch of libraries nowadays. If you don't use them, by definition, I can modify the array at any point, and then my next iteration will just break. I can get the library off the shelf, and then all my data will be immutable. One guy came from, I think, Clojure, and he wrote the whole library of immutable data structures for JavaScript, but they're very efficient. But don't make clones. Instead, it's like diff vector. So you don't pay a lot of performance penalty for using off-the-shelf immutable data. Okay, back to Lodash. Another requirement for functional language is lazy evaluation. You download this, by default, it's lazily evaluated now. Very cool. Yes? I always admired Polish developers. Yep, yep. Yeah. By the way, I will not say that Kensho is hiring, but why not open an office here? Another interesting library is lazy.js, and lazy provides asynchronous operations on a list. And it's the first time we actually see something that's not synchronous. But notice that we're using it exactly the same semantically as we used before. It's just now every number is processed or appears a second after we're done. So now if we have to talk about asynchronous, we have to talk about promises. Standard JavaScript, it's all callback based. Unbelievable spaghetti code. Like, you hear Pyramid of Doom and then all this, extremely bad. So right away, use promises. Promises wrap a single asynchronous operation. It either succeeds and you get result or fails. The best thing about this, the error handling. Now you can actually handle errors in predictable manner. Anyway, we can wrap our numbers operations in promises. Now, I told you guys you're very, very smart, so you don't have to worry about anything. You will understand this. The actual JavaScript doesn't really matter. I'll point out the important things. In this case, the important thing is I can do sequentially. I can do shortcuts. There's a lot of boilerplate. And the problem is that for every number, we have to generate a new promise chain because promise only operates once, right? So every number has to set up its own promise, and that creates a lot of boilerplate code. And boilerplate is bad. So there is something else called event emitters. It's part of Node.js. For the browser, you can get a library. That's where you want to generate and handle events over and over, right? Not once, like promise, but over and over. And also decouples, right, the source of events from processing. So if you attended the previous presentation, that's nice. So I can create new event emitter. I can say on number print, and after multiplying by constant. And I'm using my lazy sequence to generate events, and for every event, it will do something. But it's completely decoupled, and it can happen over and over. And notice there's very little boilerplate. I can take just these two important things, right? Everything but that is a boilerplate. I can create like little wrapper class, and I can say for my source, which is numbers, do something, and that's a functional callback. Again, if my print and by constant are boring pure functions, it's easy to reason about this. And we can decouple even generating things. And if we actually look at the user code, we take the source, and for source we do something, and it's all little functions. And this pattern is used in JavaScript all the time. We register callbacks for events like mouse clicks. We register communication events or WebSockets. Like I was controlling this presentation for a WebSocket, for example. So it's easy, right? We just extended the same approach to anything or everything. And yet, I feel bad, right? Like I used to do something like map and then just a callback. And now I have to do source and then on action. And what is on in this case? I used to have maps, filters, reduce. Now on is too generic. It doesn't semantically tell me what's happening. And also, I don't see how we can actually combine multiple steps. It used to be very quick, easy to create a pipeline saying map multiply, and then for each print, what do I do here? So if we go back to our original inspiration when we used built-in methods, I really want to recreate the same kind of semantic syntax. I want to say source of events, map, and then the callback could be asynchronous, and then for each, another asynchronous stuff. And I want it to work. So I wrote something called chain emitters. So I took an event emitter, and I said, well, I'll add a map function to that. And the map will process everything, but instead of just returning something, it will return another chain emitter instance. So I implemented map and for each. And now I can take my numbers and I can map and for each. So this returns another event emitter and this returns another event emitter. And now I can create pipelines. So that's cool. But now I have sequences of events. So if I don't want to process every number individually, I can, for example, write a method called buffer. And what it will do, it will keep a little buffer. And once it reaches the full buffer, then it can send the buffer all at once as one event. And now I can, for example, generate number every second, multiply, buffer them up, and then send all three numbers all at once. Very easy to do. The source code looks nice and clean, except it does now two things, right? Map transforms the data. For each, you can think of this also transforming the data, right? Does something with the data. But buffer doesn't really transform the data. Instead, it kind of coordinates the sequence of events, right? Again, you can think of this as mixing concerns, like multiplication and print. So at this point, the developer who kind of started with like for loops, right, kind of went, and everything was very natural. We want them to notice that there are two different types of operations. And if we keep implementing the stuff over and over, we soon will be boggled in complexity. So instead of implementing everything ourselves, okay, I'm going to skip this. We're going to just use off-the-shelf library. So, and conceptually, we're going to think about everything that happens as just, as an event being emitted asynchronously. Just sources, pipeline, maybe things. And all we're going to do, we're going to write the same code, but just reacts to us. So I'm going to use an off-the-shelf library called Irex. Irex is a library published by Microsoft. I think it's open source, everything. It has implementations in a bunch of languages. JavaScript is very popular library. It has bindings for all the frameworks. And here's an example. Instead of me generating a number every second, right, at kind of mixing time and generating numbers, I'm going to have one stream that just generates timestamps every second, right? So that's the first time event stream. And then I'm going to generate my numbers from an array. That means it will generate a number, let's call it at each iteration. And then I can zip those two streams together. So zip is one of those like sequencing methods that I never had equivalent when I just did array processing. But once you have to merge sequences, you have to implement this. So zip is an interesting thing. It just takes two streams, and then you can pick which value you want to actually process, or I guess pass forward. So in this case, I don't care about the timestamp. I care only about the number. So I'll return the second argument. So zip creates a new stream, and then I can run my by constant, my little pure function. In this case, it runs asynchronously, but that's fine. It's boring. What can it do? Why does it matter if it's run synchronously or asynchronously? And interestingly, I wrote stream number 3 here, but in reality, zip returns a stream, map returns a stream, and subscribe returns another stream. it's kind of like chained emitter. Every step returns something else. And now I decoupled completely my numbers, right, from my timestamps. Everything is an observable in this library. I can zip those streams. And what's good is that I don't have to use, for example, the timer. I can use any source of events. In this case, I can create events from clicking a mouse. So what this means, instead of generating a number every second and printing and multiplying and printing it, it will multiply and print a number every time I click a specific button. Now, I just removed a whole bunch of complexity from my UI, right? I'm thinking about everything in exactly the same conceptual abstraction as processing a list of numbers. Only now I have to deal with multiple streams, but it's easy. And here's what kind of tour de force. They showed this example for every freaking reactive library out there. And the example is a smart search. So you go to Google, you start typing something, and once you typed a couple characters, it actually goes and does the search and then shows you the preview of results. And if you keep typing, it will do it again and again and again. Implementing that using modern frameworks or jQuery callbacks is a pain like you would never imagine, right? And if you actually try to do it right, if you try to handle all the possible errors, and especially if you try to handle the ordering, right? Because you can, fire off a search query. It can take 10 minutes, and then you keep typing. You fire off another search query that returns right away, and then the first one returns, and all of a sudden you see, you typed, like, why my, and when you type my car doesn't start, but all of a sudden it returns results like why my wife thinks of abandoning me. No pressure, but this is how easy it is to do using reactive. You can think of all your keystrokes as a sequence of events. That's the original input. We just grab the key value. Actually, this is the whole text in the input box. We filter. That means we're not going to do anything unless you type at least 2 characters, which makes sense. We're going to throttle. That means we're not going to fire off like every millisecond a new search. We're not going to do anything unless the text actually changed. So if you fired off an event or search, and when you added character and removed it right away, we're not going to fire off. Flat map latest, the whole thing about managing the sequence is solved with one call, one method. Like, I don't have to worry about that, right? Because this is completely decoupled. And when you get the data, and it's always guaranteed to be the last data for the last event. Beautiful. So all reactive, damn it, where's the spelling error? All reactive libraries implement both array or list methods, like map for each, and also all the stream, sync, or sequencing methods. Any one of them, Irex, bacon. So just to kind of conclude our journey, the first step we have to make is start writing smaller and smaller functions, the most boring functions. And then you'll notice that you don't have to actually write a lot of them. You can use off-the-shelf library, or you can reuse boring functions. You start, kind of dipping your toes into asynchronous processing using promises instead of callbacks, and you find it's actually very nice. And then you can switch to maybe asynchronous reactive streams. So I've been preaching, right? I said, this is what I want from my team. This is how we write code. So here's our progress report. We've been writing code for 1.5 years. So where do we stand? This is not a rating. This is more like a measure of how much we use it in our code. So object-oriented stuff, creating new instances using prototypical inheritance, we almost never use in our code, right? We have it for some data, but we avoid it. Functional, we use both Lodash and Lambda, and we wrote a whole bunch of utilities that allow us to pipeline stuff like there is no tomorrow. So we actually do a lot. I'm almost done. Immutable data, we currently are not using it, but we see a need to start using it as soon as possible. And the problem is you get a piece of data from a server, you process, and then you give it to some other component, some other widget, and that widget can modify and add more, compute more, and now we have to reason, did it compute already, or do we have to compute it ourselves? So the reasoning about how data flows became a problem, so we have to use it. We're not using lazy evaluation. Lazy evaluation is useful in very specific cases when you have a lot more data than you need. In our cases, we mostly process everything. So promises, we use everything. Event emitters, we use AngularJS where a lot of events, reactive streams, we're not using, but we're strongly considering. So that's what we'll do. The future is bright. JavaScript is very quickly evolving. Everything I showed today is off-the-shelf JavaScript. I can open my browser, any browser, and it will just work. And then there is a new version that used to be called ECMAScript 6 or ECMAScript 6. Now it's ECMAScript 2015. That means they're pretty sure it will come out this year. It adds a few bells and whistles, but nothing will change in the code I wrote. Maybe it will be a little bit shorter, but conceptually it will be all the same. And finally, this presentation is available. I'll be happy to answer any questions, or I can just take applause. Yes?
How do you handle DOM updates? Because reactive programming is very nice, but then it comes to, one that has changed and you have to rebind events to new nodes, and it's just painful, and that's the biggest problem. When you stick to the, let's say, easy things like, let's say, Ajax code,
Yeah.
it might be difficult, but it's okay. But then when you have a UI that has been updated by some kind of template and cheat,
So right now, the whole rendering is taken care of by AngularJS that kind of syncs everything to digest loop after we finish processing. We have a lot of charts and tables, and there we start using React. So we compute the virtual DOM, and then only updates are sent to the actual DOM. So that's, and we actually do a lot manually. So for example, we have tables that can have anything from like 1 item to like 10,000. So we only stick in a DOM what's actually going to be visible using off-the-shelf widgets. So we didn't find so not to brag, but I'll brag. I wrote a blog post on AngularJS performance because we were running into performance problems. At some point, it was #1 in Google search for Angular performance. The DOM is not the slow part. The slow part is figuring out what's going to be visible, right? And only kind of setting that. Then the DOM is not a problem. You usually have a lot more data than what you can show. I hope it answers your question somehow.
yes.
Um,
And also, how do you handle, because you mentioned that searching, and that the biggest problem here is to handle calls that didn't come, or you have some kind of an error and you have to repeat your call.
yeah. So yeah, I think Irex. So we actually tried implementing the smart search a couple times using different approaches. It never actually worked because of natural language processing on our back end. The front end was easier. I think Irex now even includes like automatic retry as one of the methods, so you can retry things. So I think if you implement something, it's going to be generic enough so that you can actually put it in the library and not re-implement it in your custom code. So that's what we would strive for. Can I implement very generic solution?
The next problem I thought is when you use, let's say, AngularJS or any library like this, whatever, backbone or something, and you try to use Irex.js, those two ways of writing code don't match well together, and then create very stubborn code that you look at it and it doesn't feel natural, or it's just painful to understand.
I think Irex right now has pretty good again, we have not integrated, but from examples we've seen, Irex does very nice integration with Angular because it can update the data and then kick off the digest cycle automatically, so you don't have to worry about, is Irex done or not. So you actually don't see the integration pain point. I think we actually struggle a lot more with immutable data structures. The libraries are pretty new, and the fast ones implement completely different API from closure script, or we don't want to recreate all our data and our maps and for each in a different syntax. So Irex, I think, is fine. Did everyone kind of give you questions beforehand, right?
Okay, so the last problem, last question is, when you have that Irex extension and you create a lot of objects, when you create promises, etc., then you have problems with garbage collection,
Yeah.
and you have problems with huge number of, and you just have efficiency problems. But if your data stream is small or you batch it, then yeah, it's not a big issue. But if you go to, let's say, parsing that way a lot of data from, let's say, WebSocket, it might be a bad idea.
It might be. It's also the same problem you would have even if you did not use Irex, right? It's not the problem with Irex. It's a problem of your data. It's very application specific. As far as if we hit the problem, again, we have not started using Irex in our code. We can resolve like all the dumb performance issues and garbage collection too. We're not reallocating the structures over and over. Once we hit it, we'll see if there's a way to avoid the performance. In creating a lazy evaluation will help, definitely. Yes. Uh-huh. That's excellent. So the biggest thing is the programmer saying it's not natural, right? I'm so used to for loop that returns the result. For me, like abandoning the return value, because if you move to promises, you have to abandon return values altogether. Before, I kind of showed the map and print, and you can kind of say, oh, it's very artificial abandoning return values. Once you switch to promises or stream, you have to abandon. And I think that's the mental switch. That was the biggest pain point for me. Other people who start programming on the front end said kind of the same thing, like, why do I have to use map or something that doesn't return things if I can just write my logic and explicitly? So I think that transition, right, to asynchronous, no return value, just create a pipeline and everything will magically happen is the biggest point.
That's, I was going to say, that's probably all we've got time for in terms of questions. Is it a quick one? Yeah. Okay, last one.
The answer is no. Okay. No, sorry. Yeah. Yeah. So, yes, we had a lot of problems, but with amount of data we were trying to show on the screen, right? Which is, you can say it's not JavaScript specific, it's more like web browser specific. But another thing that we kind of noticed, that's why I kind of called it semi-performant asynchronous using promises. Promises are slow, and they are slower in one browser compared to the next. So we're actually looking at ways to avoid using promises everywhere.
Can we thank Gleb once again?